Okay, so you've just finished all those practice problems, and hopefully you've checked your answers with the answer key. Let's talk about what's at stake. Please turn to this page. So we talked about how in those fuel rods, U-235 undergoes fission. And when it undergoes fission, we remember that it produces, from the first page, from earlier lessons, it produces 3 neutrons, a whole lot of energy in those smaller atoms. So when all of that U-235 is used up, when all of the U-235 in the fuel rods has undergone fission, remember from the first page, this is just reviewing and kind of going over what we've already talked about. You'll remember that those are now spent fuel rods. That's the word spent fuel rods. And those now have radioactive elements in them. Those smaller fission products that are being produced, those smaller atoms, are radioactive. They're going to decay and they're going to give off alpha, beta, and gamma particles, which are bad. We went over that on the first page. We also talked about how those radioactive elements, the rate at which they decay is called their half-life. And we also learned that it can take a really, really long time for some of those elements to decay and become safe. And we talked about how it takes 10 half-lives for it to be considered safe. For example, plutonium-239 will take 240,000 years to actually be considered safe. Other elements, as well, if you look back at those tables from the practice problems, they'll take hundreds of thousands of years, some even millions of years, in order to become safe. So here's the issue. Where do we put the waste to keep us and the environment safe from it? As it decays, it's giving off radiation, which we've talked about being bad for our health, for our environment. So what are we going to do with that waste? What do we have planned? So here's what we currently do. Currently, waste is kept at the power plant for about 40 to 50 years. And it's kept in a big pool of water, and that's because as it gives off radiation, as it decays, it also produces a lot of heat, which that water helps cool it. And the structure is also made out of concrete, and we talked about how concrete is able to prevent gamma decay from escaping, and therefore it also helps beta and alpha, so it keeps us safe. And so here I have a picture of that pool. They're huge pools in big buildings. And you can see all of these circles down here. These are all the fuel rod assemblies that are submerged in water. And this structure right here, this is concrete, and the building is also made out of concrete. Okay, great. That's for the next 40 to 50 years, or 40 to 50 years after those fuel rods are taken out. But what happens when we get too many of them, as we start to increase our use of nuclear energy? Or what happens after those 50 years? That's the big question with nuclear energy. Nuclear energy is a very new technology, especially compared to fossil fuels. So there aren't really great solutions right now as to, in the long term, what are we going to do with that waste? We know how to keep ourselves safe from it in the short term, but we don't really know what to do in the long term. And there's a lot of solutions out there. One solution is to shoot the waste out into space. Other solutions are to bury it deep, deep, deep underground. Other solutions are to bury it in mountains. You might have heard of Yucca Mountain, which was something that, which was a policy that was being considered, a Native American reservation, which was considered being used as a nuclear waste facility, and they ended up stopping for several reasons. But the problem is that we have thousands of years to look forward to for this nuclear waste, and we don't exactly know what to do past the first 40 to 50 years. There's also talk about some of these solutions. Put it in a glass that's a very strong glass, and then you put it in that glass in stainless steel, and then you can surround all those stainless steel containers with clay, and that's because when you put them in the ground, you don't want water to come into contact with them because you don't want your water to pick up those particles, and then you ingest them. And then this is the located deep underground in a stable rock structure. So that's just another solution that I found online that people are thinking of doing with the nuclear waste long term. So the last thing I need you to do today is I need you to take back out your tan sheet, just like you did at the beginning, and add your final risk to your paper. The risk we are talking about is nuclear waste. And I want you to think about, is this a high impact or a low impact? Is this very risky, which would be high, or is it a risk but not that big of a risk? Radiation released by nuclear waste. And then I want you to think, is this a long-term issue or is this a short-term issue? Is the idea of nuclear waste something that we need to think about in the long term, or is it something that will impact us right now? When you're done with that, you may flip to the next page, which is your homework number 47, which will prepare you for your quiz. Next class.